So today's a pretty heavy content day. We have a lot of different definitions, so I've broken it up into 2 days. This is the video for both today, properties of algebra, as well as justifying, which we will talk about at the end. So if you're here for justification, go ahead and skip forward a little bit. I promise we will indeed cover it. In the meantime, let's go ahead and talk about some very important words that allow us to do what we need to be able to do. In 9th grade, it is not just expected that you can solve the problems, it's expected that you can also tell us why you can solve the problems and walk us through the work. So we got to go ahead and do some definitions. Hopefully some of this is familiar to you, or perhaps even common sense. But let's go ahead and work our way through them. The first one is the additive identity. An identity is what you can add and have, what can you have and have it not change? The additive identity is 0. So for example, you could take 5 plus 0, and that's still going to be 5. It didn't matter. You could add a bajillion zeros to it, and it's still not going to change. Similarly, you could go the other way. 7 minus 0 is still 7. So it's both addition and subtraction. That's kind of an important distinction to make. Okay? All right. Similarly, we have a multiplicative identity. What can we multiply and have it not change? So what number can we multiply to anything and have it stay the same? The multiplicative identity is going to be 1. Because, for example, 3 times 1 is equal to 3. Similarly, 12 divided by 1 is equal to 12. It stays the same, and that's true for any number of different problems. Let's go ahead and keep going. Let's talk about the additive inverse. The additive inverse is what you add or subtract to get the identity. What do you add or subtract to get the identity? So for example, if we had something like 4, what do you add or subtract to 4 to get the answer of our additive identity, which is 0? Well, you add negative 4. 4 plus negative 4 is equal to 0. Some of you probably wrote that as 4 minus 4 is equal to 0. Similarly, if we had, say, something like negative 9, and we want the answer to be 0, what do you have to add or subtract to negative 9 to get 0? Well, you have to add 9. We can use the same logic for the multiplicative inverse. What you multiply or divide to get the identity. So, for example, if we had, say, something like 15, and we want the answer to be 1, what do we multiply or divide to 15 to get 1? Well, we could multiply by 1 over 15. Another way of writing that is dividing by 15. Similarly, if we had 1/8 What could we multiply to 1/8 to get to 1? Well, you'd have to multiply 8. We need identities and inverses really to make sure that we can use the next 4 properties. I'm hoping these are some common sense, that we've done enough solving equations at this point that these feel very familiar. The first one is going to be the additive property of equality. It's very similar to the subtraction property of equality, multiplication property of equality, and division property of equality. The addition property of equality specifically says we may add the same thing to both sides of an equation and it won't change. So for example, if we have x is equal to 3, that's going to be the same thing as x plus 7 is equal to 3 plus 7. We may add the same thing to both sides and have it not change. Subtraction property of equality is the exact same, except instead of addition, it's subtraction. So an example could be, well, let's just keep with x equals 3. X minus 5 is equal to 3 minus 5. I'm subtracting 5 from both sides, and it stays the same. The logic continues for multiplication and division as well. So if we have x is equal to 3, we can say 2 times x is equal to 2 times 3. I'm multiplying the same thing to both sides, and it doesn't change our answer. And once again, logic follows for division. We may divide the same thing to both sides of an equation. Now, there is one huge exception. It applies to both the multiplication property of equality and the division property of equality. So make sure that you have this written down, except for 0. So for example, if we go x is equal to 3, and you multiply both sides by 0, you end up with 0 is equal to 0, which is true but not particularly helpful. On the division side, it's even worse. If we have x is equal to 3, and we divide both sides by 0, we actually create a black hole that nothing can come out of, and it's really bad. So don't do that. Don't divide by 0. It's bad. Puppies will die. As opposed to something else, any other number is fine. So if we have x is equal to 3, we divide both sides by 4, that's still fine. Let's keep going. Let's go ahead and look at the symmetric property. This is an important one. We may flip around an equation. So because of the symmetric property, we can say that x is equal to 3 is the same thing. That little math symbol there that I just drew means same thing as 3 is equal to x. You can treat the equal sign as a mirror and rotate around it. That's not always true, but in equal signs it is true. So, as a general rule, I'm going to encourage you to write your variables on the left, so something like this as opposed to the one on the right. However, the one on the right is still correct, and I'd probably leave it on an assessment. The distributive property is it's a relationship between multiplication and addition. And it's basically, I'm just going to give it this is like a very, not the most accurate definition in the world, but it'll do what we need it to. And that definition is everything gets multiplied. So for example, if we have A times B plus C, that becomes AB plus AC. The A has to multiply to the B, and it has to multiply to the C as well. All right. The associative property states that when in the same step, we may multiply or add in any order. So for example, if we have A plus B plus C, that's going to be the same thing as adding the A plus B first, and the same thing as A plus B plus C. Oops, that kind of ran off the edge of the page. I'm going to try again. Doesn't matter which order you add them in, so long as we're in the same step. This is not true if you're mixing multiplication and addition, but it is true if you're in the same part. We could also do this with multiplication. So A times B times C is going to be the same thing as A times B first, and then you're multiplying the C, or multiplying the A times, and you're multiplying the B times C first. All right, you'll notice I kind of ran into the next box, so go ahead, take a look at that, and I'm just going to kind of just erase what I just wrote. We're going to talk about the commutative property. I nicknamed this one the ABBA rule. It's similar to the last one, when in the same step. Order can change. The reason I call this the ABBA step is a very common example. This is going to be A times B. Well, that would be the same thing as B times A, and it spells out the word ABBA like the band. If you want to put numbers in it, 8 times 7 is equal to 7 times 8. Once again, this is the same step. This is not going to work necessarily if you're mixing things around in terms of like both addition and multiplication in the same problem. But for what we're doing, it works just great. It also works for addition. So you could do 8 plus 7 is equal to 7 plus 8. It works just fine that way. All right. We finally have enough information to go ahead and justify solving equations. and we can go ahead and do that. So this is going to be tomorrow's lesson. So if you're watching this for the rules, this is one lesson. We're moving on to the next lesson. Justification. It is not enough to just solve. You must tell me why. We'll do that when kind of these 2-column proofs. This is the level 4 skill for this particular unit. So if you want to get a 4 in the assessment, make sure you understand how to do this. So let's go ahead and justify each step. Okay, so we have our equation, x over 9 minus 1 is equal to 11. Now think about yesterday. What was our goal? To get the x all by itself. What is keeping the x from being by itself? Well, the 9 is one thing, and the 1 is one thing. We have to get rid of both of them. Now, according to the associative property, it doesn't matter which order we do this in. However, there's one way that's going to be easier than the others. I think it's easier to get rid of anything that's not directly touching the x first. So in this case, the 9 is actually touching the x. They've got the divide sign there. So I'm going to get rid of the minus 1 first. So how do we get rid of the minus 1? Well, we want to undo the minus sign. So what is the opposite of subtraction? It's addition. So we can add 1 to both sides. Why can we do that? The addition property, I'm going to abbreviate property of equality. We may add something to both sides of an equation. So let's go ahead and rewrite it. That's going to give us x over 9 is equal to 11 plus 1, which is 12. You'll notice, why did I pick 1 to add? Because this makes a 0, which is using the additive inverse. So another correct way of answering this particular problem would be additive inverse. Do you have to write both of them? No, but I'm a math teacher and I don't mind doing extra work, so I did. Let's go ahead and do the next step. Now what's keeping the x from being by itself? The 9. How do we undo that 9? Well, it's currently being divisioned, so what's the opposite of division? Multiplication. So we're going to use the multiplication property of equality. I'm going to get kind of liberal with my abbreviations here. Just to try to save some room. So I'm going to multiply 9. That will give us x is equal to 108. You'll notice we multiplied by 9 to get rid of the division of 9. Another way of saying this could be the multiplicative inverse. Just another way of doing that particular problem. As always, you have to put a little box around your answer. I'm going to go ahead and erase these words over here to work on our next one. You'll notice this one, we have 4 steps to justify. So let's go ahead and talk our way through it. We have 244 is equal to negative 4k plus 3. Well, what is our goal? Our goal is to get the k all by itself. We have a bunch of things in the way before we can go ahead and get rid of it. We've got the k, we have the negative 4, we have the plus 3, we have a set of parentheses. Those are all in the way. According to order of operations, which do we have to get rid of first is the parentheses. The easiest way to get rid of the parentheses is going to be the distributive property. We have to make sure that the negative 4 gets multiplied to both the k and the 3. So our first property is distributive. That will give us 244, that part doesn't change, is equal to negative 4k minus 12. Negative 4 times 3 becomes 12. All right, now it's keeping the k from being by itself. We have the we have the -4, and we have the -12. Now, the associative property says that we can do this in any order. However, I think that one way of making sure that this is as easy as possible is to get rid of the number that's not directly attached to the k's. In this case, that's going to be the -12. So how do we undo a -12? Well, what's the opposite of subtraction, which is the current relationship between the k and the 12? That's going to be addition. So if we add 12 to both sides, that will give us 256 plus 12 is equal to -4k. And that we use the addition property of equality. If you wanted to say additive inverse, that is also correct. Do you have to write both of them? No. So now it's keeping the k from being by itself. Well, we have -4. So how do we undo the -4? Well, the current relationship is multiplication. So how do we undo multiplication? Division. So we divide both sides by -4. That will give us 64 is equal to k. Oops, I missed a negative sign. That's easy to do. So that's going to be the division property of equality. At this point, you could probably get away with being done. However, you'll notice I have one more step listed. I'm going to encourage you to always keep the variable on the left. So let's go ahead and just flip this around. And we'll do it in yellow. K is equal to -64, which is the symmetric property. I like to do that because I think it's important that you have the variable on the left. It makes it easier when we start doing inequalities. Like I said, this is the level 4 skill. It is tricky to match the property to what you are doing. So make sure that you learn these properties really, really well so that when you start to use them, you have access to them in your brains. As always, let me know if you've got questions.